Welcome to our second of two videos on VSEPR theory and molecular geometry. This video is a continuation of the first video, and here we're going to look at molecules in which the central atom has an expanded octet, or ones with the central atom of steric number 5 and 6. Let's switch over to the simulation and start off by considering molecules in which the central atom has 5 pairs of electrons. For our first molecule with the steric number of 5, we have 5 bonded pairs and no lone pairs. Recall that when all of the pairs of electrons are bonded pairs, the shape that the molecule takes on is the same arrangement as the 5 pairs of electrons. So this shape is referred to as the trigonal bipyramidal shape. The best way to view this shape is to view the bonds forming in two different areas. We have a linear shape that's going along this vertical axis. We see that the other 3 bonds form a trigonal planar shape. So we have 3 atoms that are forming the trigonal planar and then 2 that are linear. So we have a pyramid above and then a pyramid below. In our first case, when there's 5 pairs of electrons and they're all bonded pairs, this is a trigonal bipyramidal shape. The 3 bonds in the plane, they form a trigonal planar shape in 120 degrees. And between the plane and those 2 bonds in the vertical axes, there's 90 degrees. Here's a shape with 5 pairs of electrons, but one of them is a lone pair. Let's hide the lone pair so we can see the shape of the molecule. Here we have the 2 atoms that are in the vertical axis forming that linear shape, and then we have 2 that are going to be slightly less than 120 degrees that are forming in that plane right there. This shape is often referred to as either seesaw or the unsymmetrical tetrahedron. Seesaw is a bit easier to remember. When we have 5 pairs of electrons, but one of those is a lone pair, we end up with this seesaw shape. That lone pair sits in the plane, and that reduces the angle to a little less than 120 degrees between the other 2 bonds in the plane. It also pushes the vertical axes bonds a little bit closer together so that they now sit a little bit less than 90 degrees between the axial atoms and the planar atoms. Our next shape is going to be one with 2 lone pairs and 5 total pairs of electrons. Note that the 2 lone pairs occupy 2 of the locations in that trigonal planar axes of the 5 electron bipyramidal shape. Let's hide those lone pairs. And this shape here forms a T. This is a T-shaped molecule. When the central atom has 3 bonded pairs and 2 lone pairs, we end up with a T-shaped molecule. It's not a perfect T because the angle between the bonds are slightly less than 90 degrees. Our final shape with a steric number of 5 is when there are 3 lone pairs. Note that the 3 lone pairs occupy the locations of that trigonal planar shape. What we're left with when we hide the lone pairs is a linear shape. When there are 2 bonded pairs and 3 lone pairs around the central atom, the molecule takes on a linear shape with 180 degrees between the bonds. Our final set of shapes here are with a steric number of 6. Here we have 6 bonded pairs and no lone pairs. This shape is referred to as an octahedral shape. This shape is symmetrical in that it looks the same from all directions, and there's 90 degrees between all of the bonds. When a molecule has a central atom with 6 valence electrons and they're all bonded pairs, that is an octahedral shape with 90 degrees between all of the bonded pairs. When we have 6 pairs of electrons, but one of them's a lone pair, we see this shape here. We see a square on one plane and then one bond sticking up. This is called a square-based pyramid. When there are 6 pairs of electrons and one of those 6 is a lone pair, we get a square pyramidal shape or a square-based pyramid. The angle between the bonds is not perfectly square, it's a little bit less than 90 degrees. When we have 2 lone pairs and 6 total pairs, the 2 lone pairs will occupy positions that are opposite to each other. That minimizes the lone pair repulsion. If we look at the shape, we see the square shape here, and that's the name of the shape, square planar, because the square all lies in a plane. When we have 4 pairs of bonded electrons and 2 lone pairs, we end up with a square planar shape where the angle between the bonds is 90 degrees. When we have 3 lone pairs and 6 total pairs, we once again get a T-shaped molecule. So note that we saw a T-shape both with a steric number of 5 and a steric number of 6. When there are 3 bonded pairs and 3 lone pairs, we get a T-shaped molecule. It's not a perfect T, the angles are slightly less than 90 degrees. When there are 6 total pairs and 4 of them are lone pairs, those 4 lone pairs occupy that square, and we end up with a linear shape. Once again, we saw a linear shape with a steric number of 5 and a steric number of 6. When there are 2 bonded pairs and 4 lone pairs, we once again get a linear shape where the angle between the bonds is 180 degrees.